right, so let's take a look at Schoology real quick. It's one of these tabs. It's not that one. Courses, algebra 2. And we are in the 4th week. So I want you to notice something. This was the practice. This is 2 whole points. So please try to just getting you to graph on the thing. But I have another quiz I put up there, 8G through 8I. And I'd like it completed by Sunday night, 11:59. Don't get that sinking feeling going, oh no, I forgot it. Because I'll keep it open. So, but if you do it after Monday morning, I might not see it right away. So please give me a heads up so I can give you the appropriate points. It's not because I hate you that I skipped it, but let's see. We're going to have, so 8G through 8I, Schoology quizzes there. We will take our quiz, our actual pencil paper quiz, on Tuesday, Wednesday next week, depending upon which cohort you're in, which of course you all are in cohort A, so we'll have that quiz. And then we're just kind of moving along. I think that's, maybe it's my day wrong. Hang on, I gotta look back.
Wait, what day? Tuesday?
Hang on, I might have misspoke, and I apologize. February 5th. Oh, I'm so advanced on the head. Oh, nope. Let's see. It'll be Thursday or Friday will be the quiz. So this 8K we'll basically do on Monday, on Tuesday, Wednesday. We'll make sure we take care of this review. And then for this Trig A, which is our next unit, after the quiz on Thursday or Friday next week, you guys Thursday obviously, there will be a video to watch to introduce the trigonometry. Sound okay? And today's notes I will give you. So we have J that I will personally hand you, and then K I will give you, which would go with Monday's remote day. Sound good? All right, let's go to the homework. And see what kind of questions I can try and help you out with. See anything on there that we're talking about inverse functions, one-to-one? Any questions on the evens, right? Yeah. 20. You got it. So it says use the composite function to verify that f at x and g at x are inverses of each other. Okay. So problem number 20 looks like this. We have f at x is equal to x to the third minus 2. G at x is equal to the third root of x plus 2. So what I want to do is I'm going to do over here fg at x. And over here I'm going to do g, change color, g f at x. And if I do that and my result on both comes out to be just x, then you're dealing with inverses. So I'm going to take this one first. And I'm going to plug it in for x. So I get blank to the third minus 2. So I'm plugging in here third root of x plus 2. Okay, so if I do that, this 3 and this 3 cancel each other out because one's a raised to the third power and one just the third root. They cancel out, so that just leaves me x plus 2 where the parentheses were, minus 2, those cancel. Okay, first step's done. We wound up with x. It appears we are on the road to finding an inverse, but you have to test both because there's something that doesn't always come out right. All right, next one I'm going to take this, and I'm going to plug it in for x right there. So I'm going to do the third root. I'm going to go x to the third minus 2 plus that 2. Those cancel, so I get third root of x to the third. Third root of x to the third is x. I think yup is the appropriate math term they're looking for. That okay? Yeah.
4.
4? Graph the original function or relation and graph its inverse function or relation. Okay. Cartesian. All right. So this is number 4. So first thing I'm going to do is I'm going to go y equals x minus 3 squared minus 1. Okay, so that's a parabola that shifted right 3, down 1. Agree? So right 3, down 1, which is there. By pattern graph, I'm going to go right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3. So it does that. Okay? So it says graph the original function or relation. Well, that is a function, but I will tell you that the inverse, because we haven't restricted it, will only be a relation because the vertical line test won't work. All right, so let's find the inverse of this. What did we do to find the inverse? What was the first step? The easiest step in the world.
Table.
Not table. I could table, but it won't show me the whole graph. Go ahead. I'm not sure what Matt. You're speaking as bad as yup. Yeah.
Take the inverse of a vertex.
Okay. Oh, I see what you're doing. I said, okay, I understand. So some of you, basically, we could, because we have that graphed, we could just flip-flop our x and y values, right? Okay, let's do that. And that's a good idea. So I think we have enough here. So I knew that my vertex was at 3, -1. So the inverse of that is just going to be flip this over. So -1, 3. And then the pattern graph still works the same. Up 1, right 1, down 1, right 1. Okay. That I like that. That seems great. Now, what I was originally, my original thought process was rather than do that, because we have the points, which is great. We just flip-flop each of the points. But my original thought was, could I have done this? Flip-flop x and y, and then solve for y. So add 1. Root. Don't forget the plus or minus. You're like, dude, what are you doing? Well, I'm going to show you. That's going to give me y minus 3, which then that's going to be y is equal to plus or minus the square root of x plus 1 plus 3. And that's actually what that sideways parabola looks like. That's actually something called a parametric equation when you do it that way. And later, when we start dealing with conic sections towards the end of the school year, we'll actually see how to make truly a sideways parabola happen, because they do exist. But this is actually a two-part part. So technically, this is the inverse relation of that. And the reason I say it's a relation is the vertical line test doesn't apply. So it can't be a function, but it can be in a relation. And I chased that dog around a tree too many times there. What else did you see on the homework you want to work out or have me help you with? We good? Going once? Going twice? Sold to the kid who's eating his own earwax. Dude, that's nasty. I know. But... All right. So, my friend, there's my main important rule. Has nothing to do with math. It has everything to do with you. If you ever have to use the restroom, you never have to ask. You just go take care of yourself. It doesn't matter if I'm up there splitting atoms. You can, you know your body better than everybody, so you take care of yourself first. Second, and this is almost as just important, I have a really bad sense of humor. I laugh when people fall. Other than that, you should be able to figure about everything out. Did I catch everybody with a some notes? Did I miss anybody? I missed you. I didn't mean to. I promised. All right. So 8J, we're going to be talking about inverse functions. All right, inverse functions. Extend the understanding of inverse functions and include power and nonlinear functions. Ooh, so we're going to talk about quadratics and third root and all that kind of stuff. When you need to find the inverse of a function that is given in function form, f of x, replace the f of x with y, because f of x means the same thing as y. It's just some mathematicians at some point said, oh, let's screw up society, and we'll put f of x now in place of y. Then switch x and y as before. Okay, I think I'm okay with this so far. Everyone's okay with f of x and y being the same thing? They're interchangeable? I know that there's some math class in the future that you can never interchange them, but this one we can. And I have nothing there. Good. All right. So find the inverse of the function x squared. F of x equals x squared. Now, notice something up here, my friends. There's a restriction on the domain on this one. We want values that are greater than or equal to 0 in the x direction. This means I'm only going to graph a portion of my parabola. Okay? And I want you to realize what's taking place here because I know it doesn't ask for a picture, but I'm going to draw you a picture anyhow. What this is this. It's not the whole parabola. If I don't draw the whole parabola, because I've restricted the domain, the x values, that's going to allow this to be a one-to-one function. And if it's a one-to-one function, that means it will have an inverse function. Or I guess I should, it could have an inverse function. So because we restricted it, that's going to take place. So on the last screen it said, hey, make f of x y, flip x and y, take the square root, did I do that right? Flip-flop x, y? Oh, square root. That should have been. Wait, what did I do? Flip-flop x and y.
Is it that the y should be squared instead of the x squared?
Yeah. Boy, I tell you, you can't take me anywhere these days. Flip-flop x and y. So I have x equals y squared. Is that right? Square root, square root. Okay, there we go. We get square root of y. Oh. That flip-flop. And I flipped again, square root x. There we go. There we go. All right, now, remember when we said this? That has to apply to this as well. That's why this only has a positive component. I don't have to do the plus or minus on this because I restricted it. And this graph would basically look like this. Okay? So it's only a portion of it. So when we restrict the domain on the original, that means that we're trying to keep it one-to-one with what we're graphing. Okay? And that means that if being I want the positive values, if that was x is less than or equal to 0, I would have graphed the left side of the parabola. And then when I solved it, I would have had, rather than y equals square root of x, I would have y equals negative square root of x, so then it would have been the bottom. So you just kind of have to keep note that those are some things that are going to take place. Is that okay? Can I move on? Boy, I don't know. I must have fallen down, hit my head a few times. Ah, sheesh. Moving on. When can you expect to have the restrictions on the value of x? When it is not one-to-one. One-to-one means that the vertical and horizontal test work on both. Work. Okay? What if I'm not looking at a picture? How can I decipher if it's going to be correct? It's not one-to-one, vertical, horizontal, vertical line test. So this basically means, in the math world, when the domain, which are the x values, and the range, y values, don't repeat with each other, or don't repeat. So I could have 3 comma 3, that's fine. That's not what I'm saying, x and y repeat. What I'm saying is, if my x values ever repeat, that's a problem. If my y values ever repeat, as far as the inverses go, that's a problem. That means it's not 1-to-1. Okay? And the answer to y is, if you repeat a value and then you take the inverse of it, so let's say I repeat a y value in my original. If that y value was repeated in my original, if I took the inverse, that means that it's going to make the x value repeat. Because remember, when we find the inverse, I flip-flop x and y, I interchange them. So that's what we're looking at here. Let's see if we can clarify this a little bit more. Find the inverse of the function up above. So 3x to the 4th. Notice my restriction. I want x less than or equal to 0. We're talking about negative numbers, yes, friends? So I'm going to first make this. Okay? Now I got to keep in mind, this means I want negative numbers. Okay. Next step, flip-flop x and y. Agree? To make this simpler for me, I'm going to bring the y over to the left side. And I'm going to get y by itself now. Agree? What root do I have to do on both sides? 4th root. Normally 4th root, we have to have plus or minus, yes? But we had this restriction, was just talking about the negatives, yes? So if I do the 4th root of both sides, because I had this for negatives, I want the negative component of that. So then I'm going to get y is equal to the negative 4th root of x over 3. Happy about that? So there's some guidance. If you see it in the beginning, you're going to make it correct in the end. If you're like, oh, that's just like a speed limit. It's just, a suggestion. I'm kidding. Speed limits aren't suggestions. But stop signs, if they ever have the white perimeter on the outside of a stop sign, that's an optional stop sign. If you don't know that or not. I'm kidding on that as well. Am I going too fast, too slow? Just about right? All right. Oops. All right. Find the inverse of the function. Are there any restrictions on the domain? Okay, so friends, right now, it's x to the 4th. X to the 4th, as far as n behaviors, looks like this. The n's are doing this. I don't care what's going on in the middle, but the n's look like both going up, up. Okay? So, we know because of shifting, this whole thing would have just moved up 2. It didn't move left or right at all. This 2/5 means it would be a little bit fatter than what the parent function x to the 4th. So x to the 4th n behaviors look like this. 2/5 x to the 4th. Watch my hands, ready? Looks like this. Got fatter. If it was a whole number out in front, it would have gotten skinnier. There's my dance moves for you. Expect to see you dancing like that at prom. And yes, I do hope you all have prom. Okay, so we have to think about it. Because we would have had basically the shape of a W, it might have been rounded, might look more like a U. I have to restrict this. So I'm going to go ahead and say, you know what? I would like to say that x is greater than or equal to 0. If you have to add a restriction, I would add the positive restriction. I might add the negative restriction if it's part of the problem. So I have to keep that in mind first. We good so far? I'm now going to flip-flop my x and y value. Agree? I might flip my whole thing over because I like the y to be on the left side. And then we start solving it. Subtract 2. Happy about that. Okay. We could multiply by a reciprocal, or we could multiply everything by 5 and then divide by 2. It's going to do the same thing to both sides. So I'm going to multiply both sides by 5 over 2. 5 over 2. Move down a smidge. Those cancel, so I get y to the 4th power is equal to 5 halves x minus 5. And let me stop there. Do you agree with the math I did? If I distribute 5 halves over the parentheses, 5 halves times x is 5 halves x. 5 halves times 2, or negative 2, is negative 10 halves. Negative 10 halves is negative 5. Agree? What am I going to have to do to get y by itself on this problem? 4th root. What did I say up above? Do we want the positive or the negative? Positive. Okay, because it's 4th root, I'm going to do the 4th root and the 4th root, and I'm going to keep it as the positive component. The reason I'm putting that little plus there is because I made a claim up above. I want my x values to be positive, so I'm restricting it. So that's allowing my, if I were to graph this with this known, it's going to be 1 to 1. If it's 1 to 1, that means its inverse is also a function as long as the inverse exists. So that's going to give me y equals positive 4th root, squeeze a 4 in there, 5 over 2x minus 5, and I'm pretty happy and content with this. Yes, I understand I have a radical in the denominator, but I'm not going to worry too much about rationalizing the denominator because people back in the olden days couldn't divide by radicals. Yeah?
How do you know the restriction is that?
Okay, great question. So this graph, if I had graphed it, would kind of look like this. Kind of look like this. Be kind of a fat parabola. If I had graphed, if I had tried to find the inverse of this, my inverse would have to be a relation because the horizontal line test doesn't pass. But I wanted to make it a inverse function. So by me putting this, means I'm talking about this side of my parabola, or my U that's flattened on the bottom. That's why I put the restriction. Once I do that, this here, because I have just a positive component, the graph of this basically looks like this. Basically looks like that. If I didn't have the restriction that I put, this graph would also have this down here. And then that doesn't pass the vertical line test, which means it's not a function. It's just a relation. And those relations, we just kind of keep them aside. We love the functions.
So you could do the x is less than or equal to 0, and it would just be the other side.
Yeah, perfect. If that became x is less than or equal to 0, this and this would be your answer. So it becomes your choice. Like if I looked on your test and I didn't have one that had a restriction on it, and you put the restriction and you put less than or equal to, I realize you're talking about this side, and this is is that. If you had this as less than or equal to, my inverse would have had a negative in front of the fourth root. So it becomes a huge choice. I know it's not a fascinating choice. It's not like choosing between the purple slushy and the red slushy, but it's as much fun as we're allowed to have in math right now. Yeah.
If you did the x is less than or equal to 0, wouldn't the inverse be directly under the other side, not? So this would be still negative numbers.
So this point would definitely be here. And then it has to reflect over this line here. So that's kind of the thing. So it looks a little trickier to do this side and this side than this side and this side. Because remember, this is the line y equals x, and inverses reflect directly over y equals x. How am I doing on time? Okay, we got some time. How am I doing on notes? I have no idea. How much more do I have? You got that? You got it? Oh my gosh, I have 3 more slides to go. Okay, fasten your seatbelt. Hang on. I'm just kidding. All right, find the inverse of this function. Now, my friends, this is x to the third. This is x to the third that shifted up 1. The end behavior, because it's x to the third, is going to look like this, where my hands are going. Yes, you might have a little wiggle here, but that's what it's going to look like. Okay? So you got to think about what this is going to look like. All right, I don't know if I have to restrict this, because I think this graph is going to basically look like this. It's going to go up 2. It's going to basically do this. Okay? That's what I'm keeping in mind. This does not become a horizontal line. This is a smooth curve. This point here in calculus is called a point of inflection, but that's like so a year from now, or 2 years from now. So first thing I'm going to do, I'm not going to restrict it because it's to the third power. I'm pretty happy about that. I'm going to get y equals 2x to the third plus 1. Now it is possible for something to the third power to have a graph that kind of looks like this. Okay? And then this doesn't pass the vertical line test. But I'm safe on this one because I just have 2x to the third. I move up 1. So I don't have to restrict this. So y equals this. Cool. So now I'm going to flip-flop x and y. I'm going to flip this over because I like having y on the left. Call me old school. All right. Subtract 1. Divide by 2. And then do what? Cube root. Good. Third root. Third root. So I get y equals the third root x minus 1 over 2. Again, I'm not too concerned. I don't think this needs to be restricted. If we were to have drawn this, it's going to look like this. Let's see. 0, 1, 1, 0. It's going to basically look like, let's see, it's going to do something like this. That's what it's going to look like. Okay. And how do I know what they look like? Because I've only taught it so many times. Once you've taught it 26 years in a row, you kind of start remembering stuff. At the 25th time, you're so lucky. Last year, I couldn't remember anything. This year, I got much better. Okay, so does everyone feel good about why this one isn't restricted? Okay, where it would be restricted is if it was a third degree, you'd have like x plus 2, x plus 4, x minus 6 broken up. If you multiply that all together, you get x to the third. That's where it starts getting the wigglies like that. But when it's just x to the third by itself, it might shift up or down, but it's not doing the fancy stuff. This one's restricted for which values? Which values am I restricted? Positive or negative? Negative. So let's keep this in mind. We have the something to the fourth, so I'm going to have to take the fourth root. If it wasn't restricted, normally the fourth root would have plus minus because it's an even root. So this is going to have the negative root of it. All right. First item, change f at x to y. Change x and y. Excuse me. I could flip-flop the whole thing. I might as well keep this tradition alive. You don't necessarily have to flip it like that, but in the world of stirrup, I don't always see things clearly. All right, let's see. So bringing this up here, I'm going to get 1/4 y to the 4th equals x minus 3/8. Multiply everything by 4. 4 times 3/8 is 12/8, which should reduce to 3/2, I believe. Take the 4th root of both sides. We wanted odd numbers, or excuse me, we wanted negative numbers. So that's going to be a negative here. So I get y equals the negative 4th root of 4x minus 3/2. And we're done. One last slide, yes? I got 9 whole minutes to do it. You guys want me to talk real slow? Cool. All right. So, I'm sorry. Sorry, I was here late last night doing basketball stuff. Man, not having fans, there was a lot of work still to do. Yeesh. Do you know that we have to clear the gym after a game, spray everything down, keep everybody out of the gym, and let it air out for 30 minutes because this is some sort of magical number where all viruses and bacteria and fungus die? Whatever. I'm not making it. Hey, this one. We have a domain that they gave us. So it's not greater than 0. It's not less than 0 or greater than or equal to or less than or equal to. The domain itself is that. Okay, so I think I can find the inverse, and then I'm going to deal with the negative 2 to 5 here in a sec. Okay? Being they're hard brackets, that means I include the points. If they were rounded brackets, we would not include them. So I want to find the inverse. Remember, f to the negative 1 means inverse, so I'm going to take this equation, I'm going to go y equals 3x plus 4. X equals 3y plus 4. Flip it over. Subtract 4. And then divide by 3. So this is my inverse. Okay? Now, let's answer these questions below. What is the range of f at x? Oh. Well, this is what I'm going to do. I know I'm going to have square brackets. Good so far? I'm going to take negative 2, plug it in. 3 times negative 2 is negative 6. Negative 6 plus 4. Negative 2. Plug 5 in. 3 times 5 is 15. 15 plus 4 is 19. My range, negative 2, 19. That was pretty simple. Just plug in the 2 end values they gave you. Now we have the easiest answers on the entire day. And if you see this trick, this kind of problem is done real fast. Ready? So when I go to find the inverse, I flip-flop x and y. I flip-flop domain and range. I flip-flop domain and range. So what's the domain of the inverse? This. What is the range of the inverse? That. Done. Blessing you. That's it. So if you realize quickly that the x value, the domain range flip-flop, you can answer this question very quickly. So this is I. Let's see. You guys want a lot of homework tonight?
No.
What about tomorrow night? The night after, Sunday night, when you kept your folder on your desk and you got to it going, oh no. What did we say we do? 8I. Your call, evens or odds? Odds? Okay. 8I odds. And then I want to do a reminder, my friends. I want to do a reminder. Remember, that's not the only thing that's assigned. I'm going to go back to Schoology. Oh, not that week. I'm going to go to week 4. So remember, if you didn't do the whole 2-problem practice quiz that I actually worked out in class, please do that, because I just want to see how you do that. Then there's a quiz 8G through 8I. It's on Schoology. Do I have any idea if you're working with each other? No. I hope you do. Do I have any idea that you're using photo math? No, you're doing it at home. I say utilize any resources you have available to you. And then next week on Thursday or Friday, Thursday for you all, we will do the Chapter 8 quiz. And then Thursday night for y'all, Friday night for the other cohort, they will have a video of Trig A to watch. And it's the very first one for Trig A you've already seen in geometry. Some of you might have learned the word SOHCAHTOA. I don't deal with that because I feel it's, the story that goes along with it is disrespectful to the Native Americans. So I make fun of the hippies. And I remember SOHCAHTOA as some old hippie caught another hippie tripping on acid. Yeah, that's recorded. It's there. We make fun of hippies, okay? I don't know. Sorry if you're a hippie and you're like, oh, I'm so offended. Get over it. I'm just kidding. Everyone know what to do? Can I stop recording? 37 whole